Okay, number 1 from worksheet 2. It says compute the torque about the pivot O generated by the 100 Newton force on a gear shift lever. Okay, so remember that torque is equal to the force times the distance times the sine of the angle. Okay, so let's see here. We've got, I'm going to redraw this kind of a triangle down here. We have a distance of 1 meter here and a distance of half a meter here. And we've got the gear shift here. There's a force that's this direction of 100 newtons. Okay, so I think I'm going to extend this line here. The reason I'm doing that is because then this angle here would help us figure out for that sine of the angle. That's kind of important. Okay, so we've got this distance is 1 meter. It's 1 meter. And this distance up here is 0.5 meters. And the force is 100 newtons. Okay, so I'm going to go ahead and put into this. That's going to be equal to the force of 100, 100 newtons times the distance away. Okay, that distance away would be, I think I'm just going to call it the hypotenuse for now, times the sine of the angle. I'm going to call it sine of A. I'm going to label this angle here A. Oops. A. Okay, well, that angle there, A, that's the same as, let's see if I can, yeah, here. That's the same as this angle here. This is also A. And the reason why that's important is because when I do hypotenuse times the sine of angle A, remember what sine is defined as, SOHCAHTOA, right? So sine of A is defined as 1 meter divided by the hypotenuse. So if I do the hypotenuse times the sine of A, that's going to be equal to 1 meter. So I don't even need to figure out what the hypotenuse is. I don't even need to figure out what A is because I know this side over here is 1 meter. In fact, always, instead of doing torque equals force times R times sine of angle, it's really the torque is equal to the force times, I'm going to modify this, maybe. There we go. It's really times the lever arm length, or the perpendicular distance. Can't spell perpendicular distance. So if you could please look at this here, we've got this force in here, and if I draw in kind of a dotted line in here for that force acts anywhere along this line here, and the distance between that line, the perpendicular distance between that line and this pivot point is 1 meter. So really the torque is simply the force times the perpendicular distance between the pivot point and a line containing the force. So let me get back to solving this problem then. So that means the torque is going to be equal to 100 newtons times 1 meter, which is equal to 100 Newton meters. Another way you could say this is 100 meter newtons. It doesn't really matter, right? What is that, associative property or something?